Welcome to Introductory Chemistry with Dr. H. This is a video about significant figures in calculations, particularly how we track significant figures when we do calculations. What I'm going to talk about today is how we deal with significant figures when we're doing addition and subtraction, multiplication and division, how we manage significant figures when a logarithm is involved, and then I'm going to talk about a situation that we typically encounter, which is we don't just have one calculation, one addition problem, one multiplication problem, but we have compound calculations where there are several operations in a row. And in those calculations, we have to think about rounding, when is it appropriate to round, and how significant figures track through all of those calculations together. So let's start with addition and subtraction. In addition and subtraction, the answer, the sum, or the difference, cannot have more digits to the right of the decimal point than either of the original numbers. So let's take this first example here. If we had 7.2167 centimeters, that number has 5 significant digits. 4 of them are past the decimal point. Added to 375.61. That number also has 5 significant digits, but 2 of them are past the decimal place. If you plug into your calculator that sum, or you just add it up, you get 382.8267. By this rule, what it says is the answer cannot have more digits than to the right of the decimal point than either of the original numbers. So notice this second number, 375.61, has its last digit in the hundredths place. That means the answer can have no more significant digits than in the hundredths place. So if we were going to use our notation that we learned for indicating where the sig figs are, we could put a bar over that digit right there. And in terms of how we would round that, since it's 2/6, we could round that up to 382.83. So the number you would actually report in a problem would be 382.83 centimeters. That would be the right number with the correct number of significant figures. Okay, let's talk about a difference. The difference works the same way. So say we had 0.1304 liters, 4 significant figures in that number, 4 of them past the decimal point to the right, minus 0.02165 liters. That number also has 4 significant digits. And in this case, there are 5 places to the right of the decimal point. So what that means is that first number is going to limit the number of significant digits in the answer because that's in the 10,000th place. That's going to be the most significant digit possible in the answer. And so this 7 is the last significant digit. And again, we have a 5 there, so we could round that up. So this is going to be our last significant digit. Since a 5 is what follows it, it's 0.1088 liters. So that's how we deal with significant figures in addition and subtraction. Multiplication and division works a little bit differently. So in multiplication and division, the number of significant digits in the answer is determined by the original number that has the smallest number of significant digits. So what you do is you look at both numbers involved in either the subtraction or the multiplication or the division. You find which one has the smallest, and the answer can have no more digits than that. The location of the decimal point no longer matters. So, for example, in this first multiplication example here, 3.6528 centimeters, that number right there has 5 significant digits. Multiplied by 0.012 centimeters, that number has 2 significant digits. So in our answer, we are limited to 2 significant digits. So when I plug that into my calculator, I got 0.0438336. But I know that I'm only allowed to have 2 significant digits, right? So that means this 3 is the significant digit. That would be the 1000th place is where the significant digit's going to be. And now I'm going to round. I'm going to go 0.044 centimeters squared is the final answer with the significant digits represented. So you can see in all these problems, I'm going ahead and calculating, punching the numbers into my calculator with the full number of digits that are given. And then I'm identifying the place where the significant digit's then going to be, and then I round at the very, very end. Okay, so let's do a quotient or a division problem here. If we had 7.8372 liters squared divided by 56.1 liters, if you just plug those numbers into your calculator, you get 0.139700538, or maybe even more digits if you have a fancier calculator than mine. But the important thing is, remember, we are limited by the number that has the smallest number of significant digits. So 56.1 has 3 significant figures. That means the answer, regardless of where the decimal is, the answer is only going to have 3 significant figures, right? So what that means is 1.39, that's where our significant digit's going to be. So we know that this is the place where the last significant digit's going to be. And so again, we have this rounding situation. So this is going to be equivalent to 1.14 0 because we would round that 9 up to a 10, and that would increase the significance of the 4 there. And we need to be really careful to make sure in that answer that we indicate that that trailing 0 is also significant. So one way we could do that is by putting a bar over it, 0.140. This is a number that is less than 1, but that trailing 0, the 0 to the right of that 4, is also significant. So we've got to make sure that we indicate that it's significant. Another way we could do that, right, is to use the scientific notation trick. We could write this number similarly as 1.40 times 10 to the minus 1 liters. And that would also indicate that we have 3 significant digits in the answer. That number, 1.40, is a number greater than 1. That means any zeros to the right of the final digit will be significant. And so that 0 then is indicated as being significant. So oftentimes it's convenient to convert the number into scientific notation to make sure you're totally clear about the significant digits in the final answer. All right, let's move on to logarithms. Logarithms. So in logarithms are a little bit tricky. So one way to think about logarithms, when you take the logarithm of a number, you get an answer, and in that answer, the number to the left of the decimal really indicates the power of 10 in the original number. So since this number is 77, right? So the power of 10 there is in the tens place, so it's like 10 times 1, it's almost 10 times 2, right? So if that was a number like 777, that number would be a 2 there. So that number, that first number, the one to the left of the decimal, really indicates to you the power of 10 in the original number, right? So here, since the tens place is occupied with a 7, that number is going to be a 1. So that number really isn't significant. So the way this rule reads is there are as many significant digits to the right of the decimal point in the answer as there are significant figures in the original number. So the way we read that is, this is the original number, 77.562. So in that number, there are 5 significant digits. So in the answer, the 1 doesn't count, but everything past the decimal does. So we have 1, 2, 3, 4, 5. So that 4 is going to be the number that holds the place of the last significant digit. And again, because an 8 follows that number, we would round that up to, let me write it, 1.88965. Okay, and so that logarithm with sig figs is 1.88965, and the rest of the number is removed. So that's how you deal with logarithms when you're computing the significant digits when working with logarithms. Okay, so compound calculations. This is actually what we run into most often in chemistry, where we have a calculation within a calculation within a calculation. So here, what I would recommend doing, the best way to do it is just use the normal order of operations that you would use and do the calculations one at a time and track the sig figs in each step. So I made up an example here that involves a logarithm, that involves a quotient, and also involves a subtraction. So this will give us practice with all the different rules. So in this computation, the first thing that I would do is start with the subtraction problem, the one that's in the brackets. So sort of order of operations tells us, because that's in parentheses, we need to do that subtraction first. And we know we are limited to the hundredths place in the answer, so I'm going to take 3.71 minus 0.256. And so this simplifies to 3.454 there, and I'm going to indicate the sig figs here in just a second. Divided by 42.57. So we know that we're limited to sig figs now in that hundredths place. So I'm going to put a bar over that because I now know that that's our limiting sig figs. So that number only has 3 sig figs, and that bar there indicates that. Now I'm going to go ahead and do the quotient, and I see that the top number has 3 sig figs, that's why the bar is there, and the bottom number has 4. So my answer, I'm going to need to limit it to 3 significant figures. So I'm going to divide by 42.57. And so when I get that, what I see is that number is 0.00, just 1 0, 0.0811369509. Okay, that's a lot of digits there. But what I know, right, is that I'm limited to 3 sig figs. So the last significant digit in that number is that 1, that second 1, because the 2 leading zeros don't count. And so I have 3 significant digits, 811. Those are the ones that count. So I'm going to leave all those numbers in my calculator, and I'm going to go ahead and compute that log. Notice I'm not doing any rounding until the very, very end. So now I'm going to take the natural log of that number, and what I'm going to get is, I'll just write the answer here, minus 2.51616158, or no, 6168. I have too many ones in there. I'm gonna erase that. I'm gonna do it again. 0.5116168. Okay, so there's the number right there. And now we have to apply that last rule. So in the original number, I have 3 significant figures. And so I know that I have 3 significant figures past the decimal point in this final answer, right? So that means this 1 right here is the last significant digit in this number. And so that's in the thousandths place. So I would write this number with significant digits as 2.512 because I need to round up because that 6 is there that follows that. That follows that 1. Okay, so there we go. So that's the way the number would look. And I'll go ahead and put a bar over that second 1 to indicate that that's the one that that is significant in that answer number. All right, so we've talked about how to deal with significant figures in addition and subtraction. We've talked about how to deal with significant figures in multiplication and division. We've talked about how to deal with significant figures with logarithms. And then the most common situation is like the one we did right here at the end, where we're dealing with significant figures in compound calculations, where you're doing multiple operations. And again, what you do is you use your order of operations and track the sig figs through each step that you do using a bar, but keeping all the numbers in your calculator. And then at the end, you round the final number to have the correct number of significant digits based on the final answer that you get when you plug it into your calculator. So thanks for watching. I hope you found this video useful.